There seems to be a mysterious ticking noise. Kind of catchy. It reminds me of ordinary differential equations.
An ordinary differential equation, or an ODE, is an equation containing one independent variable and its derivatives. Here we have an equation that can be expressed as f prime equals negative h plus e times f, where h represents how hungry Ron is, and e represents the rate at which frogs hop away and escape. We see that both parameters are negative, so the rate of change of the chocolate frogs will be decreasing. We're going to learn how to solve for the variable at any given time, but first we'd like to know a little bit more about the properties of this equation.
ODEs. ODEs.
Autonomous!
An autonomous differential equation is one that does not depend on time. That means that t will not appear explicitly in the expression. This is different from a non-autonomous differential equation, such as this one, which contains the parameter t squared.
ODEs.
Autonomous!
ODEs.
An ODE containing a y, f, or any other independent variable with two primes represents the second derivative of a function y. You may have seen this notation in your calculus class. If that is the highest derivative in your equation, you can classify the equation as second order. In our differential equation, f prime equals negative h plus e times f, we only have one derivative, so we say that it is first order.
Autonomous!
A forced or driven ODE is one that has a term that depends only on an independent variable or is a constant. Do we have any of those in our ODE? Well, do you see any terms that don't depend on f? If we were to expand out the equation, we should see that each of the terms depends on f. So this equation is called unforced or undriven.
ODEs.
Autonomous!
ODEs.
Autonomous!
What is a linear differential equation? Well, I like to ignore the primes when I think about linear versus nonlinear ODEs because they can be distracting. Remember that a second derivative is not the same as a second power. An ODE will be nonlinear if the equation contains dependent variables that are squared, cubed, or are arguments of a trig function, like this one. In our example, we don't see any of those since we just have f to the first power, so our equation is linear.
Autonomous!
Sing a song all day long about D's.
I found the source of the mysterious ticking noise. It's a finite time blow-up.
Yay!
Separable, 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 separable.
A separable differential equation is one that can be rearranged so that the independent and dependent variables are grouped on different sides of the equation. Then we can solve this equation using integration. We'll show you what that looks like using our example. Now we found the solution to our differential equation, and Voldemort has sent everyone to infinity and beyond with finite time blow-up. What now? Go solve some separable DEs and subscribe to our YouTube channel. We're currently working on Mud Angst, in which a freshman Mud student agonizes about declaring CS or engineering as a major. He'd either have to defer all his requirements till senior year, or stop sleeping till then. See you next time!